Okay, good day. So, hello again. So, next one is chapter 11. In this lesson, I will talk about the working drawing. So, that means all the information about graphic drawing will be assembled in this chapter. All everything will be put in the working drawing. Let's see in chapter 11. So in this lesson, the topic I will talk about is the introduction, the detail of the drawing, and the assembly drawing, and also assembly section. For the dimension, we just have done the previous section, this is the previous chapter. So we will not do that again. So for the introduction, the definition of the working drawing is a set of drawing used during the work of making a product. So that means if you would like to produce something, some object, you need or the working drawing is required. So what you need to put in working drawing then? So you should have the detail of your drawing or everything that to represent how you make it. And also you may need the assembly drawing to say how many components and how they put it together. So that's the thing you need for working drawing. And next one, definition of the detailed drawing is a multi-view representation of a single part with dimensions and nodes. So for the multi-view, the orthographic we have done before midterm exam. So that will be your detailed drawing, your orthographic views, top, front, and right side. But the thing you need some more is the dimension that we just have learned in the previous chapter. Dimension and nodes to put in your detailed drawing, in your orthographic one. And for the assembly drawing is a drawing of various parts of a machine or structure assembled in their relative working position. Okay, so the purpose or an objective or the aim of each part. So for the detailed drawing is conveys the information and instruction for manufacturing of part so that the all information in the detailed drawing you need, because when you would like to make it, you need all that detail, all that information to say, to like help you until you get the object done. And the purpose of assembly drawing to convey first complete shape of the product to make sure that it go together well, and second to overall dimensioning for the total dimension when they put it together, what it should be, how big of it, and relative position of each part. You have too many parts, too many components, you have to know which one relate to each other. And the last one is functional relationships among various components. Functional of each part, sometimes they have to fix, sometimes they can move along a line, along a rod. So that's say the functional relation. Okay, for the detailed drawing, some information in the detailed drawing, you need to put general information. And you show the general information in the title box, blocks. The title block, I will show it in the figure later. And the second one is parts information. You have to show the shape description in the orthographic views, and you have to show the size, location, the dimensions of your parts. So you put it with the objects view, the orthographic views. And for specification, sometimes you need some spatial information to represent like a fillet or material or the surface, you have to sometimes put notes in the detail drawing. So for the general information you put in your detail drawing, in the title box is the name of company. The title block have to show the title of drawing, like a part's name. Drawing sheet number, maybe sometimes you have more than one drawing, you just need to put sheet number. And the name of the drafter who draw it, who is the checker to make sure that it's correct, and relevant dates of action. Sometimes you create it today and you have a revised versions, so just put relevant date of action. You draw, you check, or you approve on that day. And you may need to have a revision table, but when you do some revised version, just put the table. First revisions due on that day, and 2 weeks later you have another revisions, the second revise, so to put it in the table. And the three of them here that I put it in the red box is the unit. You have to say what unit you use for this drawing. And the scale, you may need to have like a full scale, half scale, or large scale. So just say what scale you use in that object. And the method of projection, you use first angle, put the symbol there. Third angle, put the symbol in the title block to say the method of your projection. So three of this is I think is the most important one that you must have to put in your drawing. Okay. So for parts information, you need to say shape, what it looks like by using your orthographic drawing or pictorial drawing. So 2 dimensions or 3 dimensions. And for the size, you need dimensions and tolerance. But in this course, I just need you to have dimensions only, not tolerances yet. And for specification, sometimes you need how many parts you have, part number, or maybe you have too many components, you have to put number for each component. And the name of each component, the number required, how many of them. Type of material you use, sometimes you use metal, wood, plastic, just say type of material used. General notes and heat treatment, that is the method how you do your material. And surface finish and general tolerance. So for the blue one, I would like you to do that. But for the black one, it's just optional. It depends on you. If you would like, just do that. If you don't, just leave it. Don't need to put it in your final project. Okay. But pictorial one, I think it's quite necessary when you put it. When you put your object in like a pictorial view, like isometric view and oblique view, that might be easy to look at your object and make more clear of the shape of your object. So for recommended practice, draw one part or one sheet of paper. Recommended. But sometimes if you have a very small piece or part, maybe you can put more than one part in one sheet. And if not the case, apply enough spacing between parts. Draw all parts using the same scale. Otherwise, the scale should be clearly noted under each part's drawing. You have to make sure that it's clear. Standard parts such as bolt, nut, pin, bearing do not require detailed drawing. Just say your bolt, what the standard metric size, just say the standard part. Okay, this is your paper sheet. So when you place your title box, it will be out there. The thing I would like you to do, you need part name, material type list, method of your projections. Okay, that's the thing you need to put on your title box. Just a blue one that I would like. And also this part, the scale as well. Unit scale and method of projection. Okay. And for the orthographic one, just put it there and complete the dimensions of your orthographic as well. Say part number, part name, material, and number required as well. And if you have some specification, just put note there. Unit, fillet, round size. That's it. And this is your method of projection. To say this is your third angle. Okay, for example, interpreting detailed drawing. For example, this one, you have one object there, one part. Your title box to say that the method of projection, the scale, that's good. Date of your sketching, who is the drafter, who is the checker, and the name of the part, the company. And you have orthographic there and all the details there. And this symbol is for surface finish, that you don't need to do that in this course. Just put your orthographic and the dimensions, just normal dimension. That's okay. So orthographic views, dimensions, don't need to put tolerance yet. And surface finish, I don't need it yet. General notes, to say what the specification of the surface, or some fillet, some round, some chamfer. Title box, that you need to do that. Revised table, if you have some revised versions, just put in the table. And this is the tolerance that allowed, plus or minus 0.02. And this is the projection method. Okay, for assembly drawing. Type of assembly drawing, you have exploded assembly drawing, which is parts are separately displayed, but they are aligned according to their assembly position or sequences. And another type is general assembly drawing, that means all the parts are drawn in their working position. And another type is the detailed assembly drawing, which is all the parts are drawn in their working position with a completed dimension. The thing I would like you to do is just the general assembly drawing. Just in this course, it's basic one and general one. General assembly drawing. All parts are drawn in their working position. Let's see. This is the exploded assembly, but I don't need you to do that yet. But if you would like to do, you can do it. So for example, like this, you have a pictorial representation to have all the parts exploded. To see this part, how when you explode it, put it far from each other. And when you have all assembly finished, if you get it like this is finished product. When you have explode view, we do like this. And for the orthographic representation, when you do explode assembly, you can do on orthographic as well. You will see it like this. That explode view. Next one, the general assembly that I would like you to do is like when you put all the parts in the working position, so we put it together like this, show in pictorial, 3 dimension. In orthographic view, you can have the general assembly as well, put it together, it will look like this. Also, you can have a section view with them for the general assembly. This one is another general assembly. So when you do the dimension on the general assembly, the only dimension related to machine's operation are given only, not all the dimensions you put in the assembly view. Just the thing that related to machine's operation. So for this one is for orthographic wheel and have the assembly all the part together that show in the orthographic. Only dimension related to machine's operation show. The other thing that will turbulence your reading, just leave it out, not show it. This is the example of the general assembly. Okay, you have to put the number of the part. This is number 1. The number 1 is say the tail stock beds. Okay, material is the cast iron 1. Require the number just one piece. And number 8 is clamp handle. This is the material and this is the number of the piece, just one piece. And next one, like number, for example, number 11. Number 11 is the half fin hexagonal jam nut. We need 2 pieces. That's it. That's the table of the list of your part, and the name of your part is there, the number, material, and requirement. And number 3 is the detail assembly. So you put all the part together and also show the detail of your part, the assembly or each part together with will be like this. That will be too difficult to read for you just now. So in this course, recommended to use the general assembly like this. That's okay. But when you have a higher level of education or the next course, you can do it like this, the detail assembly, by using a program to help you to generate the detail assembly. That will be more easy. But in this course, you have to do it by hand, so that will be too complex and not easy to read. So next one, required information in general assembly drawing. The information you need to put in general assembly that you have to do in your final project is all parts draw in their operating position. Next, part list. You have to make a table and put the list of your part and show the material, what you have, and you have the bomb. So the number to represent which part you identify which part you have the bomb, like a balloon to show the number and say that number is blah blah blah. So for the part list in the table, you should have the item number, you should have a part's name, show the material, and require of quantity, how many of them. And in the general assembly, you have to show little lines with the balloon around part number. And machining and assembly operations and critical dimension related to operation of the machine. Okay. When you're placing all information for this course, I would like you to put the assemble part there and put the reference number with the balloon number in the middle. This is the projection method. General notes, if you have it, just put it there, and the title box there. Just put it, make it easy. Part list, just put it there. Okay. For the part list with the bomb, you have to locate above or beside the title block. Fill the table from the bottom. So number 1 will go bottom there. Number 1, number 2, number 3, and up there if you have the another part list. So the first one just go at the bottom first. Okay, like this. Number 1, what's your part's name? And this is the material, that is the quantity required. That, for example, number 2, number 3, just go up there. Okay, this is an example for the auto-arrival place of bomb. So you have a part list there. Okay, and that's the bomb to represent which part, which number. And step to create assembly line. First one, analyze geometry and dimensions of all parts in order to understand the assembly step and overall step of device of machine, so that you have to think about when you make it or you produce so how you create it, so that you help when you do the assembly drawing. And next one, select an appropriate view to make sure that you get the right view to show obviously what the shape of it. Okay, and third, choose the major parts, for example parts that have several parts assembled on. And fourth, draw a view of major parts according to the selected view direction. And 5, add detailed views of the remaining parts at their working position. 6, apply section technique, where relative positions between adjacent parts are needed to clarify. 7, add balloons, notes, and dimensions if you need it. And 8, create BOM, bill of material, so a table that you have a number of part names, material, and quantity. That the BOM, BOM, that you have to create the table on top of your Titan box. Okay, general practice. So the number of views can be 1, 2, 3 or more if you need it, but it should be minimum. Just have as much as you need. Don't make it too much or too many. Just minimum. And a good viewing directions is that represents all of parts assembled in their working position. That the good viewing direction. Just when they're working, how they look like, that will be the good viewing direction that you will represent. Okay, for example, this is the selection of necessary view. You have part A, that front view and right side view, and part B, just the right side view. And then sometimes you put it in like an orthographic view like this. And another way you do it like have the right side view and put it together with part B. This is part A and part B, part A and part B. So just different view. So as you can see, which one is an appropriate view assembly drawing? I will say student B is the better representation. Can see it's obvious that part A and part B will go assembly together like this way. Next one, hidden line usually omit unless they are absolutely necessary to illustrate some important feature that the reader might otherwise miss. But in this course, I would like you just to no hidden line on assembly view. Just omit. So hidden line omit for this course. For example, you have part A and part B. If you put it together, if you go like this, if you put it together, we go like this, or if you put it together, we go like this, A, B, C, or D. So for A, it's a very good, very perfect one. That's clear. B is not good enough because you can't see inside here. C as well, you can't see that hidden line there to say part B, how they go. So the perfect one is A. Okay. So that is to represent a clearly assembly view. Next one, part A and part B, and then when they go together, you will see like this or like this. So I would say that the A one is the perfect one to say that there's something inside, that why you can see the hidden line. But part B is very poor, that you can't see anything inside. So just go for A. That's a good one. Next one. Part A and part B. Go together or go together like this. A is a good one, a perfect one. And also, in this case, B is also okay, because now we have orthographic view like this, and then we put it together to get assembly view. It's also clear if we have this and this together. It's okay. And A is also perfect. And next one is a general practice. A section technique is usually need to clarify matching of the part A and part B. When they put it together, we go like this, but we can't see obvious that something inside. We just recognize with the hidden line. It's correct, but it's not obvious enough, not clarity. So we use a technique of section technique to help. That will be better like this. To see that the section line will go a different direction, to say that it's a different material, different pieces, different part. When we do the drawing on your paper size, we get it like this. That better and more clear. Next one, section line practice. Do not draw section lines on sectional view of standard part. Threaded fastener, don't do that. Don't do section line on that. For washer, no section line on that as well. And for the sharp, pin and key, do not draw section lines. So, 3 of them. Fastener, washer, sharp, pin and key, no section line on that. For example, we have this part, clevis made of steel, arm made of steel, and pin made of steel as well. But for pin, no, do not draw section line for pin. Let's see, when we do assembly step, the clevis and the arm, put it together, and then we put the pin in the hole. Okay, when we do assembly, we go like this, and then use the section technique to help to make it clear. So which one is appropriate one, A or B? Okay, from what I have said, pin, key, fastener, washer, no section line, so we go like A. B is poor, we don't need section line on the pin. And then when we have no color, if we go like this, this is more clear on pin. Example 2, we have support made of steel, sharp made of steel, and pin made of steel. Okay, type of pin. You put support there. When you assembly, you put sharp there and put it in the hole of the support, and then put type of pin there to lock it together. Okay, when you do the drawing, which one appropriate, A, B, C, or D? So for A, everything have a section line. It's not go like that. B, for sharp, no section line. And C, sharp and pin no line. And D, sharp and pin no lines is good. But the different thing is to say that the pin go inside the sharp, you have to show hidden line too. Because the technique of section line that sharp, pin and key, no section line, That's it, good. That's it, good. This one, the pin have section lines. You don't have to do that. But the difference between C and D is you have hidden line here to represent the pin go inside the chart. When it have no color, it will be like this. Okay, next one. Example number 3. You have the clevis, arm, and pin. And when you do assembly, you put the clevis with the arm and then put the pin and on that hole. Okay, that we go the blue pin go there. And then when you do the assembly view, which one is appropriate, A or B or C? Okay, pin section technique, we don't need to put the section line on pin. So A is good, but it look difficult to understand. B is good and it's more clear to say there's something inside. C is also good because we have a blow canal section to show just the inside what we have, and that when we do no color it go like this. Okay, that's it for the assembly drawing. Okay, I hope that you enjoyed it and use that knowledge and all to apply on your final projects, and then try to use it for in the future. You might have to use it when you working with some company, and also for the next course that will be like a drawing 2, that you will have computer aid program to help you to create a drawing, mechanical drawing. Okay, thank you for enroll this course, and I hope you enjoyed it and understand it and use it for for future, that might be useful on your work in the future as well. Okay, looking for your final project to represent all the parts you have chosen or you designed, put it assemble together and show a correct view of your object. Okay, good luck for your final exam as well. Bye.